Hey guys, Coach Cook here. Got Jackson and Shania helping me out, so thank them in class whenever you see them. But this is a video about enthalpy. Okay, so we're gonna learn how to do single problem enthalpy questions, or maybe it'll say enthalpy of the formation. But it's a little bit different than Hess's law, and people are getting those mixed up. So I wanted to make sure I did a video about that. So Hess's law is when there's two different equations, you combine them and you do that, and you add the enthalpy numbers. Okay, but what we're doing here is a single equation, and we're going to have different steps that we have to do for that. So, first of all, if you see this on your test, you should automatically think, okay, I got to look at this fancy chart over here. Okay? So all you do is you come back over here, and you look at the different molecules that are in this system, in this equation, and you're going to use the numbers from the chart to plug it in. Okay? So what's our first thing? Al. Well, I'm going to go ahead and save you some time. I looked through this chart. There is no AL in that chart. So anytime you have a number that doesn't have an AL, you put a 0. Go to the next one, the next molecule, okay? I have Fe2O3, okay? If we go over to the chart, I look. Where is it? I see it right here. Fe2O3, okay? I look over, and here's the value that I have. So I'm just going to go over here again and plug that in, and the value is -822.2. Okay, and you guys can also see that this is all in kilojoules per mole. Okay, so that's kind of important too. So keep going down the line. I'll save you some time. This one is on the chart. I'm going to have a value of 1669.8, and then I'm going to look for Fe, and guess what? It's not on the chart, so I'm going to put a big old 0. Okay, and we can get into the whole thing about diatomic elements. And, the phrase we used to use about have no fear of ice cold beer, all of those are not going to be on the chart, but we can get into that more later. But for right now, just plug it in. Now, next step, I need to add every side of the products and every side of the reactants, add these things together to give me two different numbers, okay? So, if they have a coefficient, I need to multiply those numbers by the coefficient. Luckily for us, in this problem, the only ones that have coefficients are zeros, so those numbers times that is just going to be a 0, right? So when I combine these things, it's going to be the same numbers, right? Because they're dealing with 0, so no big deal. All right, next step. I have my numbers after I combine the product side and the reactant side. Now I'm going to take the products minus the reactants. So this minus this. So once I plug it in, it's going to be 1669.8 minus -822.2. I have negatives just when I'm writing them on the board. I put them in parentheses to make sure that it's a little bit easier to read. So negative minus a negative, okay? And then just plug it in your calculator, guys, and what you should get is -847.6 kilojoules per mole. So that's going to be our first delta H. See how easy that is? No big deal. So let's do the same thing over here. So I'm still using the chart that's all the way over there, but I'm going to save you some time. Just trust me that they're actually in here, okay? And I found the values already. So first thing, I look up this one on the chart, and it's going to come out to -1206.9. Go over here. I'm going to look this one up. It's going to be -635.1. And then I'm going to go over here, and this one's going to be -393.5. Now, I got all these values, if you follow me by looking at the chart. If it's on there, I just plug it in. All right, back this way.
Dude, you back in the building.
One second, got an announcement.
In the data room. Cake in the data room. Make your way down.
Cake, guys.
Cake. Someone say cake. It's in the data room.
Oh my God. All right, sorry. So, funny announcement. Hey, man, that's how we roll at the Tequila. So, here you go. Got these numbers now. So, what do I have to do? I have to combine them. Okay? I don't have anything to combine over here, so that's easy. That's just going to be -1206.9. For this one, when I add them together, it's going to be -1028.6. Now, same thing. I have to do the products minus the reactants. So, -1028.6 minus -1206.9. Okay, I put them in parentheses just to make it easier to read. Plug that in your calculator. Okay, what do you get? You're going to get 178 Now, here's part of the problem that we haven't addressed yet. We need to learn how to tell whether these things are endo or exothermic. Now, there's another video you guys should watch about all of that, how to tell, and I give a little story, okay? But basically what it comes down to is if something is negative, it's going to be exothermic. If something is positive, it's going to be endothermic. So with this one, this is a positive number. So if I was to ask you, what kind of a reaction is this? Okay, you would say it is endothermic, okay? Over here, if it is a negative, okay, we did all this work and I said, what is this? Is this negative? Is it endo or exo? You would tell me it is exothermic because of the negative number. All right, guys, watch the videos, get ready for the test, and good luck.